So, hello students, in the series of the water resource engineering subject, we were discussing various forces acting on the gravity dam. Now, come to the next pressure, that is silt pressure. So, the construction of the dam across the river carrying sediments result in the reservoir sediments, which cause an additional force act on the upstream section of the gravity dam. As you can see in the figure, the upstream section of the dam, the silt deposit at the upstream section during the construction of this dam, and the height of this deposit silt is hs. As you can see in the figure, the height of the silt deposit hs, which cause an additional force acting on the gravity dam, and the intensity of that pressure will be 1 by 2 Ka gamma S into Hs square, where gamma S is the saturated density of the silt and Hs is the height of the silt in reservoir, and where Ka is the earth pressure coefficient, and the value of this earth pressure coefficient can be calculated as 1 minus sin phi upon 1 plus sin phi, and that is equal to 10 square 45 minus 5 by 2, where phi where phi is where phi is angle of internal friction of that silt. Okay, next is wave pressure. Next is wave pressure. The waves are generated on the surface of the reservoir due to blowing of wind, which cause a pressure additional to the static water pressure towards the downstream side of the dam. As you can see in the figures, wave propagate in the water and which will act in the upstream section of the dam. The wave pressure depend on the height of the waves developed in the water. As you can see in the figure, the height of the wave, the wave 2h by 3 of the pre-surface level or full supply level of the dam, and where is h by 3 h by 3 below the water surface level. And you can see the pressure distribution due to this wave is like this, and the intensity of this pressure will be 2.4 gamma w into hw, where gamma w is the unit weight of the water and hw is the height of wave, and the total pressure can be calculated as Fw is equal to 2 gamma W into Hw square. Now, how to calculate the height of this wave? So, height of this wave can be calculated by following relation. There are two relations. That depend upon the phase length f. When the phase length is greater than 32 km, then height of wave will be 0.032 under root v into f, where v is the bending velocity in kmp's and f is the phase length in kilometer. And there is another relation when phase length is less than 32 km. SW is equal to 0.02 and 0.032 under root v f plus 0.673 minus 0.27 f raised to the 3 by 4, right? So next is ice pressure. Ice pressure is more important in cold countries. The ice is formed on the water surface of the reservoir is subjected to expansion and contraction due to the temperature variation. The dam face has to resist the force due to expansion of the ice, and these forces act linearly along the length of the dam at the reservoir level, and the intensity of this pressure Intensity of this ice pressure may be taken as 50 ton per meter square. However, the exact value depends upon the temperature. And next one is wind pressure. The intensity of the wind pressure may be taken as 1 to 1.5 kilonewton per meter square of exposed area.